Okay, so consider this parabola. Show that the line through the point 3, -7 with the slope -2 is tangent to the parabola. Okay, so we got this parabola. Let's kind of draw what's happening here. We have this parabola, really simple parabola. It's just x equals 2. Okay, that's that line right there. And then we have this 3, 1, whoops. No, don't do that. We have this 3, 1, 2, 3, and then 1, 2, 3, 4, 5, 6, 7. Down to -7, 3, we have this point. And it says that there's this line that is tangent to the curve that goes through that. So first let's see what this line is. What could this line be? I mean, all we need is a point and a slope to make a linear equation. So we have y minus -7. You know, if we're treating this as like x1, y1. And then equals -2, x minus 3. And let's simplify it down to just y equals, because we could actually have the same equation of a line, and it would look really different depending on what point you choose on the line. So, but if we make it, if we rewrite the linear equation so that it's written as a function of x, and what that means is it's so that the y is alone, then that's unique to that line. So I'm gonna go ahead and solve for y here. On the right side, I gotta distribute that -2 and subtract the 7 from the other side. And so I get y equals -2x minus 1. So here's the line that it's talking about. Okay, it says the line, that's this guy. Okay, now we have to just show that this is tangent to the x squared curve. So let's see if we could find a tangent line that has -2 as a slope. Okay, because if we could find the tangent line that has a -2 as a slope and find out where it is, like where its point of tangency is, then we can see if this is that line. So we're essentially just going to find where the tangent line, where there's a tangent line that it gives me -2. Okay, so y prime would be 2x. This is the function that will give us the slope at any point. So like if we plug in 3 into this, it'll give us a slope right here, right? That's what that guy does. Now the slope that is in question is this -2. So where does y have a -2 as a slope? So we plug in -2 for the y prime to figure out where. Okay, and then when I divide by 2 from both sides, I get -1 equals x. And so it looks like at -1, we have a point that is where we have a slope of -2. So if that's where we have a slope of -2, what is that point? Okay, what is this point right here? Very easy to find out. We just take the function y and we plug in -1 to it. So we plug in -1 and we square it. We get 1. So it's 1, or -1, 1. So at -1, 1, we have a slope of -2. So now we take our slope and our point and we write an equation. So our slope right now, I shouldn't write m equals -1. That's like how you write it in algebra. Let's say y prime of -1 equals -2. So we have our slope and our points. Let's write the equation. So that would be y minus 1 equals, that's this one right here, okay, equals -2, the slope, times x minus -1. That's this -1 right there. Okay, so this is actually a positive. I'm going to distribute this -2, so I get -2x minus 2, and then I'm going to add 1 to that from the other side, and it looks like I get y equals -2x, and I get a -1, which matches this guy. So now you can say, because they match, you can say, therefore, the line through the line through 3, -7 is tangent to x squared. Done. Okay, so that's that part. I feel like that was the hardest part, but because like whenever you first read a problem, you kind of have to try to understand what's going on in that problem. And here I can see, whoops, that was a really bad line. Here I can see, okay, that makes sense. Okay, we were able to prove that that was a tangent line to that curve. Okay, the next thing says, find another line through 3, -7 that is tangent to the parabola. Now, if let's think about that for a second. Is there another line that would go through that point that could be tangent to this parabola? Just looking at the picture, it looks like I could draw another line this way that would be tangent to the parabola. Maybe it wouldn't look exactly like that. I mean, that kind of looks straight up, but it does look like there is another line that exists. So how can we find what this other line is? Because I don't even know the slope this time. Before I knew the slope, and so it was easy for me to find where it had that slope. But how do I do it now? Okay, so this is what I'm going to do. I know that we want one of the points in our linear equation to be 3, -7. But I don't know what the other point is. Okay, so here, let me write this out. Maybe this would be easier to understand. Now in calculus, we write the linear equation, the point slope form equation, as y minus f of a equals f prime of a times x minus a. Okay, now I'm using f just to differentiate between the function name and the y, but this one is defined as y equals x squared. So I'm going to say that f of x equals x squared, just kind of give it a different name. Okay, so now I know that the point I want this line to go through is 3, -7. So I'm going to plug in -7 to the y, and I'm going to plug 3 into the x. And now what I want to find is, what the heck is that a? What would that a be? Okay, so now I can start plugging some stuff in, because we know what this guy is, and we know what this guy is. And then we could find out what the a is. This guy is x squared. So we just plug in the a to that and rewrite it. So it would look like this, -7 minus a squared. We also know what this guy looks like. He's up here. So that would be 2a. And then we have 3 minus a. So now that looks like something we can solve. All right, right? Let's distribute that 2a to be 6a minus 2a squared. This side we have a -7 minus a squared. It looks like this is a quadratic. Now in order to solve a quadratic, you got to get everything on the same side. You got to make the quadratic equal to 0. And then we can possibly solve this using factoring, or we can use the quadratic formula. So let's put everything on one side and see what we got. I'm going to move everything to the left side. So that means I'm going to add 2a squared to both sides. So I'll have -7, and then I get an a squared, and I'm going to subtract 6a from both sides, and I'm going to rewrite it so it's all clean. So we have a squared minus 6a minus 7 equals 0. All right, let's factor this and solve. Hopefully it's factorable. Let's see. Yep, -7. So a times a minus 7 and +1. So -7 and +1. That would multiply to give me -7, and that would add to give me -6. Perfect. Okay, and when we set both of those equal to 0, we get +7 and -1. And hey, check that out. There's our -1. You remember our friend right there, -1? -1 is one of those x values that would give you a line that goes through 3, -7. So that was kind of tricky because we were given some parameters in order to find the two different points, or the two different x values that would give you a line that would be tangent through x, or tangent to x squared. we knew what the function was. We knew what the derivative function would be. We just didn't know what these were. Okay, so we found two A's. Those are 2 points of tangency for a line that goes through 3, -7. Oof, that was crazy weird. So it says find another line through the point. Okay, cool. Well, we already know -1. Now we got to do 7. So if I plugged in 7 to f, I would get 7 squared, which is 49. So 7 comma 49 is the other point that we can go through. What is the slope at that point? To find that, we just take the slope function, we plug in our 7, and that would be 2 times 7. That's from this guy right here. And so that's 14. So we have a point and we have a slope. Now can we write a line, an equation of a line? Yes, we can. So we go y minus 49. And actually it's crazy because you can use this point or you can use this point. I'm going to use our new point. He's our new friend. And our slope is 14. And then the other x is 7. And because the question doesn't say write as a function of x or solve for y, then you don't have to. So that's one answer. You don't need to write both, but I'm going to go ahead and do it. The other answer is y plus 7, 14, x minus 3. Okay. All right, so we got A and B done. Let's take a look at C. And I kind of don't like this question anymore. It says, is there a third line through 3, -7 that is tangent to the parabola? Because the reason why I don't like this is because it says justify your answer. I feel like you can answer this by explaining it and not having to justify. Usually when a question in calculus says justify, that means you do some math work to prove what you're about to say. Well, we already did all the math work. We showed in B that there's only 2 x values, 7 and -1, that would go through 3, -7, and then be tangent to the line x squared. Now, this question might also be there because of other ways that you can solve this. I think this is the most direct way to solve this, and so I don't feel like there's more work that needs to be done. You can just say no because we only, let's say only 2 x values were found that would give us a tangent line to x squared. And contain a point, contain the point. (3, -7). Done. That's the end of that guy.